Hello everyone. Um, I'm going to present my work at UvA and Prague University of Amsterdam, which is studying the cumulative effect of interbrain synchrony on collaborative decision making. I first start with the motivation. So basically, uh, decision making is clear. It's choosing between two options, and there are different types of decision making. One of them is intuitive decision making, which is a fast decision making without logic. And collaborative decision making is the type of decision making that more than one person is involved in making that decision. So several organizations like firefighters, emergencies, police officers, and even in business and meetings require collaborative decision making. So studying this phenomenon is an important issue. The aim of this research, which brings us the bigger picture and the future work, works as follows. So, why are we doing this? Several real world situations need collaborative decision making. So, based on that, what we're doing is we try to train teams to decide better collaboratively in emergency situations like firefighters, police officers, and emergency teams. So, how are we planning to do that? Of course, based on interbrain synchrony and using neurofeedback devices, which improves the interbrain plasticity of the participants. So, what is the evidence and how would we know that this would work? We have done some literature review, which I will include part of it in this presentation. But before that, we go to the background. So, what is interbrain synchrony or hyperscanning? Interbrain synchrony is the measurement of synchrony of brain activities between participants in a dyad while performing joint actions. There are several measures that compute interbrain synchrony, like Pearson correlation, PLV, WTC, or PDC, which you can in the literature, the details. But for collaborative decision making, there are several factors that are involved, like trust, fairness, courage, learning, memory, risk taking, and so on. There are specific games designed to measure these aspects of decision making, collaborative decision making, some of which include Prisoner's Dilemma, Ultimatum Games, Chicken's Game, Iowa Gaming Task, Gambling Card Games, and Trust Game. We have studied different types of games, economic games, to choose from them and choose the collaborative decision making framework. In our literature review, we studied 18 papers, which include papers from 2000 to 2024, and they were only considering empirical evidences, and they were using EEG and FNIRS measurements for interbrain synchrony, and they were only focusing on healthy subjects and collaborative actions, and they only focused on human subjects, not mice or monkeys, and also no moral decision making was involved in our literature review. We focused on interbrain synchrony and collaborative decision making, and the similar research papers were excluded and the duplicates were excluded. So there are several research questions that were mentioned in the literature review and the papers in the literature review, some of which are listed as follows. So the first question was, can interbrain synchrony predict defection or cooperation in the game? The second question was, does interbrain synchrony verify the behavioral data that we capture? The third question was, what brain areas and brain processes are involved in collaborative decision making? And finally, what is the relation between interbrain synchrony and other variables that might relate to collaborative decision making? Variables like trust, fairness, and so on that we explained before. So we have several findings that I refer you to the literature review, but the one that relates to this project is cooperation with versus defection. So in one paper, we found that less synchrony is seen in defection, and based on that, they predicted the defection in the game. And also in another paper, they found that less interbrain links and higher modularity were present in defection. So based on this connectivity of the uh, brain regions between the participants, which was measured based on interbrain synchrony, they predicted the result, the outcome decision. So let's go back to the big picture. We see that interbrain synchrony can predict collaborative decision making based on the literature. But the question is, how can we improve collaborative decision making using interbrain synchrony? So in order to do that, not only we need to predict collaborative decision making, we need to be able to know when it happens and when the collaborative decision making is performed. And of course, that should be based on interbrain synchrony. So we define our research hypothesis as follows. Collaborative decision making emerges from accumulation of interbrain synchrony. So why do we come up with this hypothesis? The first reason is that we know that decision making emerges from accumulation of evidence based on the literature in decision making. And also we found that interbrain synchrony is a predictor of collaborative decision making. So by combining these two findings, we define a research hypothesis. Later, we define our research questions as follows. First question is it possible to predict collaborative decision making based on interbrain synchrony? The second question is, can we predict collaborative decision making using cumulative models? And the third question is the cumulative predictor of collaborative decision making based on interbrain synchrony diet specific, or is it like a global model? We designed our experiments by asking participants to sit next to each other and perform the prisoner's dilemma game while we were recording their interbrain synchrony. The prisoner's dilemma game is a game that the participants decide to cooperate or defect, and so they have two choices, cooperate or defect, and each of the participants have to choose one of these. And based on the results of their decision, they get some points. If they both collaborate or cooperate, they get the most points, and if they both defect, they get the least points. During our experiments, we defined some checkpoints in each trial. So the first checkpoint was when we show the rewards. The second and third checkpoint were when each player makes a decision and press the button to defect or cooperate. And the final checkpoint was when we show the results. So basically we defined the interbrain synchrony and we computed the interbrain synchrony in the time window between showing the reward table and the last player making his or her decision. Drift-diffusion model is a model that helps us predict the decision and the outcome of decision based on the timing and also the input signal. There are several parameters that are learned through the training of the DDM model, some of which include boundary separation, starting point, drift rate, non-decision time, and the noise. The drift diffusion model is composed of two main terms, which consist of the drift term and the diffusion term. And by computing the derivative of these components and combining them, we get, for each time point, we get the decision. Before doing the experiments, we get the results from another study, which was the mother and child interbrain synchrony during mutual visual search task. And we performed our model, we run our model on their data to see how it works. And in that experiment and in that study, the mother-child dyads took turn to locate targets animals. But in our experiments, we recruited 4 participants from 24 to 26 years old, all master students, 3 females and 1 male, and one pair. We asked them to fill a questionnaire, and one of the questions was the iOS measure. And for one participant, the iOS measure was 3.5 out of 7, and for the second pair, it was 7 out of 7. For the neuroimaging experiment, we used the Unicore device, the headset, the EEG headset, with 8 channels, which you can see the channels on the graph. And we pre-processed the data by using first the bandpass filter from 0.5 to 80 Hertz, and then we used the ICA referencing the CZ to remove the eye blinks and the other artifacts. So we find brainwave frequency bands from delta, theta, alpha, beta, and gamma, which you can see the frequencies in the slides. And then we computed the PLV Interbrain Synchrony for each frequency band and each channel on the EEG headset. So we have like 5 frequency bands and 8 channels. So we have 40 Interbrain Synchrony variables for each pair of participants. For the statistical analysis, we trained the models by first using stratified threefold cross-validation to compensate for the imbalanced data. And we defined the output variables as either both participants decide to cooperate or not, or either both participants decide to defect or not. So we consider mutual defect or mutual cooperation as the outcome variable. For research question 1, which was whether Interbrain Synchrony can predict cooperative decision making, we used SVM model. And for the second question, which was whether a cumulative model can predict cooperative decision making based on Interbrain Synchrony, we used the Drift-diffusion model, which is a cumulative model. Let's go to the results. The first result that we found is that we found higher Interbrain Synchrony in delta and theta frequency band. The second finding was that the difference between brain regions and channels was not significant in terms of Interbrain Synchrony. And the third finding was that we found higher Interbrain Synchrony in pair 2, which has the higher iOS measure. As you can see, the prediction results, which relate to research question 1, which was the SVM model, we see that pair 1 in mutual collaboration got 53% accuracy, and for mutual defect, they got 59% accuracy. And for pair 2 with higher iOS, we see that the collaboration resulted 59% accuracy, and for the defect, we got 75% accuracy. This was the results for research question 1, which we used the SVM model. Research question 2, which was the VDM model, which is a cumulative model, we got 44% accuracy for collaboration in pair 1 and 47% accuracy for defect in pair 1. And for pair 2, we got 58% accuracy in collaboration and 76% accuracy in predicting the mutual defect. The discussion section. First, we see higher Interbrain Synchrony in delta and theta band, which aligns with the previous study that we did in reading other papers, as you can see. And delta and theta frequency band relate to judgment, executive control, behavioral change, social empathy, and cognitive control, which makes sense. Um, the other finding was that we found higher interbrain synchrony in in pairs in the pair which has higher IOS. So the effect of social engagement and social empathy can clearly be seen in defining interbrain synchrony. The third finding is that cooperation doesn't necessarily lead to higher interbrain synchrony. So we saw relatively similar interbrain synchrony between cooperation and defect. And that could be because of that several brain activities are involved in the uh, process of decision making. So the, as the time window was big, we were not able to specify which brain processes were involved in making the decision. So interbrain synchrony was composed of different brain processes, and the result of interbrain synchrony for between cooperation and defect were similar. The next point is that we find higher prediction performance in mutual defect, which is strange. So it's easier to predict defect. Actually, this aligns with the previous study in the literature review. And we can conclude that the reason for this higher accuracy is that the defect is more imbalanced. The data in defect is more imbalanced. So most of the data items correspond to class 0, which is not defect. And if the classifier assigns more probability to the class 0, it would get higher accuracy. Although we use like F1 measure and stratified cross validation, but still the imbalanced data can affect the model. The other finding is that we see higher prediction performance in pair 2 with higher IOS, which is a very important finding, which means that IBS is actually informative for predicting predicting collaborative decision making. So when we have higher IBS, we have higher prediction accuracy. And the final and most important finding is that we see a close performance measure between the DDM and SPM in predicting the collaborative decision making, which is strange because SPM is a very complex model, but DDM is a linear model. And if we use a simple linear model like linear regression to predict logistic regression to predict the collaborative decision making, we wouldn't get a good result. But when we use a linear model like DDM to compute the decision, we get a similar performance as a complex model like SPM, which means that timing is an important factor is in predicting the performance, predicting the collaborative decision making, because the complex SPM doesn't have a factor like timing, like the timing of the decision, and it only considers the interbrain synchrony. But the simple DDM model, which is a linear combination of the interbrain synchrony measures, uses timing as well. So as you can see, timing is informative in predicting uh, collaborative decision making, which actually answers our research question and our hypothesis. So to conclude, we can see that interbrain synchrony and decision making are related. We have done a literature review on that. Next thing is that we can predict the decisions based on interbrain synchrony. This is the first research question that we did using the SPM. And also we have seen other papers that did the same approach with different models. And the finding says that yes, predicting the decision based on interbrain synchrony is possible. But the contribution of this study is that we study the cumulative effect of IBS in predicting the decision. So basically, the accumulation of the brain signals actually result in the final decision. So we consider this hypothesis answered because we use the cumulative model to predict the decision making using interbrain synchrony, and we got similar results as the standard and complex um, models which didn't consider the timing and accumulation of the accumulation effect. So we see that the interbrain synchrony timing is also important in predicting the decision. So our finding is that first, interbrain synchrony is a good predictor of mutual decision, more significantly the mutual defect, which is the first research question. And the second finding is that a cumulative model is also able to predict this phenomenon, like the defect, mutual defect in decision making. So how can this work be useful? First of all, we get a better understanding of the nature of interbrain synchrony in decision making, which is that the accumulation of the brain signals is actually resulting the final decision. Of course, further study needs to be done in this domain, but this is a new direction and new gateway to this type of research. And secondly, if we do further experiments, we might be able to design neurofeedback systems that helps people to decide better and improve their interbrain synchrony by using neurofeedback signals. So yes, we might be able to increase interbrain plasticity in emergency teams and firefighters or yeah, emergency teams by using neurofeedback systems that can predict the timing of the right decision based on the interbrain synchrony. And we saw the basis of this research in this project, which is using a DDM model to predict the decision-making result based on interbrain synchrony. The limitations of this work is, first of all, this is just a case study. So we just studied 2 pairs of participants, and further rigorous research is needed to study and prove this result. And of course, answering research question 3 depends on further studies, because we were not able to say that if these models, these DDM models, are actually diet specific or global. Can we train a global model for all participants to predict their decision time based on interbrain synchrony, or do we need like diet specific models? We cannot answer that unless we do several experiments on several participants and diets. So that's another limitation of this study, which can be improved in the future work. Thank you very much for listening to our presentation, and you can contact me through the email, and looking forward for further discussions in future. Thank you.